Hey everybody, so this lesson is going to look at something called transversal lines and the angles that are created by transversal lines. So what is a transversal line? It is a line that intersects two or more lines. So for example, we have this diagram right here. I've got these two lines right here, and I've got this line that intersects those two lines. So this line here down the middle is my transversal line. And the cool thing about transversal lines is that there are some more properties that can help us figure out what all of these angles are. Especially if we are given one of the angles for any one of these values, we can easily figure out what the values of every other angle is using the properties that we talked about in the previous lesson, as well as some more properties right here. So we're going to talk about, there's going to be some more definitions, some more names. The first one is called a corresponding angle. Corresponding angles are angles that are in the same kind of position, but in two different places. So for example, this angle number 4 right here is in like the bottom right section of this kind of, I guess, like 4 quadrant thing. And this angle 8 is also in the bottom right of this section right here. So angle 4 and angle 8 are called corresponding angles. Same thing with 1 and 5, they're both in the top left. Same with 2 and 6. Same with 3 and 7. 2 and 6 are in the top right, 3 and 7 are both in the bottom left. So those are all corresponding angles. Alternate interior angles are angles that are in opposite position between two lines intersected by a transversal. Now that's like a lot of technical mumbo jumbo, that's kind of like a lot of gibberish, but the whole idea behind it is whenever you have a transversal and you have two lines that are kind of crossing that line, always try to look for like a Z shape or a Z shape, I guess, because we live in Canada. So we've got like this, and then this line, and this line here. The angles that are inside that Z, so 3 and 6, are called alternate interior angles. So I'm going to say look for a Z shape. So just like how I drew a Z right here, this angle here and this angle here are going to be equal to each other, the one in like kind of the inside of the Z shape. Okay? Same with 4 and 5. If we kind of draw like a backwards Z shape, so like boom, boom, and boom, we've got angle 4 that is inside the kind of Z shape here, and angle 5 is inside the Z shape here. Those two angles are also going to be equal. Another key word here is interior. Interior means it's inside, in between the two lines. So that's why we're not talking about 1 and 2 or 7 and 8. We're only talking about the angles that are inside these two lines. And alternate, basically they're on opposite sides of each other. So angle 3 is on the left of the transversal. Angle 6 is on the right of the transversal. Those two are equal. Same with 4 and 5. They're inside between these two lines, but they are on opposite sides of the transversal. Okay? The opposite of that is alternate exterior. So exterior, those are my 1, 2, 7, 8 angles because they are outside of the two lines that we are looking at. And alternate means it's going to be opposite. So 1 is on the left of the transversal, 8 is on the right of the transversal. 1 and 8 are going to be equal to each other. And same thing with 2 and 7, they are also going to be equal to each other. So we're going to be using these properties where we are going to be given an angle, and then we are going to figure out what all of the other angles are using one of these properties that we have talked about. Okay? Now just one more thing here. There are the properties here that say corresponding angles are equal, alternate interior angles are equal, any interior angle on the same side, so for example 3 and 4, are going to be supplementary. Remember, supplementary means it adds up to 180. And any exterior angle on the same side are also supplementary. So for example, 1 and 2 are exterior angles. They're also going to add up to 180 degrees. So we have example number 2 here, which I've already started drawing on. We're going to try to figure out what each of these values are. So we already know, based on like these numbers here, angle number 6 is going to be 58 degrees. That is the information that it is giving you in the question. And really, it's up to you how you want to tackle these problems and how you want to think about it in terms of its properties. Okay, so for example, angle number 6, which is 58, and angle number 7 are vertically opposite, which we talked about in the previous lesson. Vertically opposite means they are across from each other. When they are across from each other like that, they are going to be equal to each other. So angle number 7 is also 58. Again, it's up to you how you would like to continue with this. In the example here, they start talking about angles number 5 and 6. So like we set up here, angles number 5 and 6, whenever they are on the same side, they are supplementary. They add up to 180. So that means angle 5 is going to be 180 subtract 58, which is 122. And then again, depending on how you want to approach this, angle 5 and 8 are also vertically opposite. So these two are vertically opposite, which means they are equal to one another. So that means angle 8 is also going to be 122. All right? And now that we know what these 4 angles are here, we can say what these top 4 angles are because they are corresponding to one another. So angle 1 and angle 5 are corresponding. Corresponding angles are equal. So angle 1 is also 122. 2 and 6 are corresponding. So angle 2 is also going to be 58. 3 and 7 are corresponding. So that is 58. 4 and 8 are corresponding. So angle 4 is 122. Okay, and that's kind of also listed here in the box. But again, there are multiple ways that you can approach this problem. Maybe you wanted to use the alternate interior way of talking about it. So if we make like the Z shape right here, angle 3 should also be 58, which we found. 4 and 5 are also alternate interior. So 4 and 5 should be the same, which they are, 122. We can also use the alternate exterior. We can talk about supplementary angles. There are many different ways that you can approach this problem, but the whole idea is really you only need to know one angle to be able to figure out the other angles using whatever property you choose to use. All right, so the last thing that we are going to talk about is just angles in triangles, which you probably would have already seen in trigonometry, but just in case you haven't, there's just a note here that says the sum of the interior angles in any triangle adds up to 180. So whether I draw a triangle like this, whether I draw a triangle like this, it doesn't really matter. We could also draw something really skinny like that. It doesn't matter what the triangle looks like. The angles inside the triangle always add up to 180. So for example, if we added up these 3 angles here, 83 and 42 and 55, I don't have a calculator handy, but if you were to add them on a calculator, plus 42 plus 55, they always equal to 180 degrees. Also, because we are talking about angles, don't forget to put the degree symbol. Again, it's not the biggest deal right now, but once you get into grade 12 for essentials, they start taking off marks for if you don't have the proper units. So for example, because we're talking about degrees, you always want to make sure to put whatever it is. Don't just put the number, put also the units of whatever it is that you're measuring. So don't forget about that. All right, other than that, there are a bunch of practice questions. Give them a try and let me know if you have any questions.